Quantitative ability, problems on boats and stream. Let us consider B as the speed of boat in still water or so-called stationary water. The boat can move with its actual speed if the water is stationary. But this is not the situation in case of a river. In case of a river, a water is flowing at certain speed. So if I assume W as the speed of water current or stream, then there arises two speed. The very first is downstream speed. Now what is this downstream means? If the boat is moving along the direction of stream, यानी पानी के बहाव के साथ, then the speed of water increases the speed of boat, which is called as downstream speed. Basically, it is equal to speed of boat in still water plus speed of water current. So downstream को हम denote करेंगे by a variable d, which is equal to speed of boat in still water plus speed of water current, because speed बढ़ जाती है. The second is upstream. What is upstream? If the boat is moving against the direction of stream, then the speed of water reduces the speed of boat, which is known as upstream speed. Resistance आएगा जिससे बोट की स्पीड कम हो जाएगी. So upstream speed कितनी होती है? That is equal to speed of boat in still water minus speed of water current. So these are two speeds, that is downstream and upstream. Downstream is पानी के बहाव के साथ and upstream is पानी के बहाव के against. So let us summarize this. Downstream speed, that is along the flow, is speed of boat in still water plus speed of water current. Upstream speed, that is against the flow, that is speed of boat in still water minus speed of water current or flowing water. If we want to calculate the speed of boat in still water, अगर हमें downstream और upstream speed पता है तो that is nothing but average of downstream speed and upstream speed, d plus u divided by 2. Similarly, अगर हमें downstream और upstream speed का पता है तो we can find out the speed of water current by this expression, downstream speed minus upstream speed divided by 2. Please remember these four expressions as this will be used in solving the problems. Also, this topic is related to time and distance. So the relationship between the three variables are like this. Distance is a product of speed and time. Time is equal to distance divided by speed, and speed is equal to distance divided by time. Let us try out some numericals based on this topic. Problem 1. A man swims downstream 30 km and upstream 18 km, taking 3 hours each time. What is the speed of man in still water? सबसे पहले हम डाउनस्ट्रीम और अपस्ट्रीम की स्पीड पता लगाएंगे. So downstream speed, it is equal to 30 km he is traveling in 3 hours. So 30 divided by 3, that is 10 km per hour. उसी तरह से what will be the upstream speed? He is traveling 18 km upstream in same 3 hours. So upstream speed हो जाती है 18 divided by 3, that is 6 km per hour. Now it is asked in the question, what is the speed of man in still water? So we can straight away use the expression speed in still water, that is B is equal to average of downstream and upstream speed. So d plus u divided by 2 I will do. That is 10 plus 6 divided by 2, which comes out to be 8 km per hour. Option D is the right answer. Problem number 2. A man can row 8 km per hour in still water. When the water is flowing at a speed of 2 km per hour, it takes him 2 hours to row to a place and back. How far is the place? You can pause this video and try the question on the paper, and once you have solved it, you can again play the video to look for the solution. Okay. What is given in this question? Speed of man in still water has 8 kilometer per hour. So I will consider B is equal to 8. And the flowing water speed is 2 kilometer per hour. So I will consider W is equal to 2. So B is given as 8 and W is equal to 2. Can we find out downstream speed and upstream speed? Yes. So downstream speed is equal to B plus W. यानी 8 is the speed in still water plus water current का speed 2 किलोमीटर पर आवर है. So downstream speed हो जाती है 10 किलोमीटर पर आवर. उसी तरह से upstream speed is equal to 8 kilometer per hour, that is speed in still water, minus speed of water current. If we do, we get upstream speed as 6 kilometer per hour. Now the question is, if he is going to a certain place and returning back in 2 hours, how far is the place? So I will say here, the place is suppose d kilometer away from the starting point, suppose. Now time to go downstream plus time to come upstream back, the total of this is equal to 2 hours. Now what is time? Time is equal to distance divided by speed. अगर वो d किलोमीटर जा रहा है डाउनस्ट्रीम at the speed of 10, तो कितना समय लगेगा? It is d divided by 10. और वही d किलोमीटर अपस्ट्रीम वापस आ रहा है at the speed of 6, तो कितना समय लगेगा? It will be d divided by 6. So we can further write as d by 10 plus d by 6 is equal to 2 hours. Now solving this particular equation by taking LCM of 10 and 6 as 30, we get expression something like this. If we simplify this, the value of D comes out to be 7.5 kilometers, which is option D. Problem 3. 2 points in a river are 24 kilometers apart. A boat takes 9 hours to make a round trip between 2 points. If the water is still, the boat can make the round trip between the 2 points in 8 hours. How much is the speed of stream? Means in this particular question, you need to find the speed of water current W. Is the speed of boat in still water given? Directly it is not given, but we can calculate. As he can go 24 kilometer far and return back that same 24 kilometer in 8 hours if the water is stationary. So speed of boat in still water is 24 kilometer going plus 24 kilometer returning, in total 8 hours in still water. So that is equal to 6 kilometer per hour. This is the speed of boat in still water. Now, if the water is not stationary, it is flowing at the speed of W, then the boat takes 9 hours as mentioned in the question. So I will say time to go downstream plus time to return upstream is equal to 9 hours. Now how much kilometer he is going downstream? Obviously 24 kilometer, and same 24 kilometer he is returning upstream. Now we can express this time of upstream and time of downstream as distance divided by speed. So I will write it like this. So 24 किलोमीटर जा रहा है और डाउनस्ट्रीम स्पीड हो जाती है b प्लस w, जबकि b यहां पर हमने कैलकुलेट किया है 6 और अपस्ट्रीम स्पीड हो जाती है 6 माइनस w. Simplifying this particular equation like this, we can calculate the value of w, which comes out to be 2 kilometer per hour. Option A is the right answer. Problem number 4. A man can row a distance of 5 kilometers in 30 minutes with the help of tide. The direction of tide reverses with the same speed. Now he traveled further 15 kilometers in 5 hours. How much time would he have saved if the direction of tide is not changed? You can pause the video and try this question on the paper. It's a logical question. And once you have solved it, you can again resume the video to look for the solution. Okay. Here we don't require much calculation. It is very simple and straightforward question. As 5 kilometers he travels in 30 minutes with the help of tide. Hence, it's obvious that further 15 kilometers he can travel in 3 into 30, that is 90 minutes or 1.5 hours if the direction of tide remains same. But as the direction of tide reverses, he travels further 15 kilometers in 5 hours instead of 1.5 hour, which means he is requiring 3.5 hours extra as the direction of tide is reversed. So if the direction of tide is not reversed, he would have obviously saved 3.5 hours. Option B is the right answer. Problem 5. A boat covers a certain distance downstream in 1 hour while it returns back in 1.5 hours. If the speed of stream is 4 kilometers per hour, what is the speed of boat in still water? So यहाँ पर हमको W दिया है as 4 kilometers per hour and we need to calculate the speed of boat in still water means B. Okay. Timing for downstream is given as 1 hour and time for upstream is given as 1.5 hour. So let us assume that he is going a distance of d kilometer downstream. So the downstream he is going and the time required is 1 hour. So I can write it as distance divided by downstream speed equal to 1 hour. What is downstream speed? It is speed of boat plus speed of water current. Speed of water current problem में mentioned है as 4 kilometer per hour. Therefore, I can write as d is equal to b plus 4. This is my equation number 1. Now, when he is going upstream, the time required is 1.5 hours. That 1.5 hour is equal to same distance d divided by upstream speed, which is equal to speed of boat minus speed of water current, and 1.5 hour converted to fraction as 3/2 hours. Okay. Now here I can write distance is equal to 3/2 times b minus 4. We can equate equation 1 and 2 as the left hand side of both the equation is same. So I will write b plus 4 is equal to 3/2 into b minus 4. Solving this particular expression, we can calculate the value of b, which comes out to be 20 kilometer per hour. Option D is the right answer. Problem 6. A boat travels 25 kilometers upstream in 45 minutes and returns back the same distance in 30 minutes. How much is the average speed of boat for the entire journey? Now, one thing you should remember here is that average speed is never the average of given speeds. Then what is average speed? Average speed is total distance traveled divided by total time taken. Now what is the total distance traveled here? He is going 25 kilometers upstream and also returning the same distance downstream. So the total distance traveled is 25 kilometers plus 25 kilometers. So I will write in the numerator 25 plus 25. Total time taken. जाते समय अगर उसको 45 minutes लगते हैं, 45 minutes I divide by 60 to convert it to hours, and आते समय अगर 30 minutes लगते हैं, which I will divide by again 60 to convert it to hours. So this is the total time taken. Solving this particular expression, we get the average speed as 40 kilometer per hour. Option C is the right answer. So these are the types of questions which are asked in boats and stream in your competitive exam. Thank you for watching this video.